Hey guys, welcome to Unit 3, Lesson 2 Notes on Scale Drawings and Models. By the end of the day, you will be able to solve problems about scale drawings and models. So, to get you a little warm up, let's do a scale drawing. How you take a scale drawing is you take whatever the dimensions are here, and then you scale them up to be in these bigger squares. So if we wanted to look at like this ear right here, so I'm gonna look at this ear right here. And I see that this black part is a little halfway over here, and then it goes up and over, and then goes all the way to the corner, and then kind of does like this sweeping here, and then goes a little into this square, and also we've got this pink part that comes like there and then goes up to like there kind of, and that'll be that kind of ear type of deal. Or since we're working in Notability, we just kind of trace around the whole rabbit, and then we'll take everything in there and then scale it up using the pencil tool. So if we take this guy, we duplicate him, we drag him over here, we can just weep and then make him fit in this box, and then there we go. We've got our bigger rabbit. Isn't that great? Okay, cool. So the question is, how much bigger is he here than he is there? In order to figure that out, we need to use proportions. So I'm going to make this a little smaller. A scale model, or I got ahead of myself. A scale drawing or a scale model is what we do when we need to represent something that's too large or too small for actual size. You see a lot of scale models of buildings or of cars, or you can also see scale models of like tiny bugs. They'll blow them up and get bigger. So let's make one. Let's start out by drawing a rectangle that's 4 units wide and 6 units long on the grid. So we go over 1, 2, 3, 4. This is not going to be perfect, but that's okay. 4 units long, 4 units wide, 1, 2, 3, 4, 5, 6 units down. We make a rectangle out of it. So we've got our original rectangle, and it is black. Now, it asks us to draw a second rectangle, and our second rectangle will be, so the ratios, the size of the first rectangle is 1 to 2. So that means we need to take our 4 units and make that twice as big. So it was what, 4 by 6? 4 by 6. So because we're going 1 to 2, that's 4 times 2 and 6 times 2. Well, 4 times 2 is 8 and 6 times 2 is 12. So we're going to go over 1, 2, 3, 4, 5, 6, 7, 8. And down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that's 12. 7, 8, 9, 10. Yeah, okay. And then we make a rectangle for that. Ta-da! Now we're going to draw a third rectangle so that the sides of the first rectangle are 2 to 3. Ooh. So we need to take our original 4 and our original 6, and this time we're going to go times 2/3. And here we're going to go times 2/3. So that'll be 4 times 2/3. Let's do some work here. 4 over 1 times 2 over 3 is 8/3, which is also 2 2/3. And then 6 times 2/3, 6/1 times 2/3 equals 12/3, which is 4. Guess I should have made that purple. Cool. So now we're going to make a smaller rectangle. What did we say? 2 2/3 by 4. So it's over 2 2/3. Sure, that's that. By 1, 2, 3, 4. 2 2/3 by 4. There you go. Those are scale models. Now, if we did this correctly, we could take our original rectangle. Oh, man. Okay, whatever. I didn't select the whole rectangle, but that's okay. We could take our original rectangle and scale him down, and it would still match. Man, my iPad's on the fritz today. It would still match those same dimensions. Isn't that so cool? We can also take our original rectangle, scale them up, and it should be the same dimensions. Ta-da! Isn't that so good? So good. Okay, great. Well, now let's put this into practice. Okay, so let's say you've got a map of Texas, which is the biggest state in the continental U.S., and on your map, every inch is 50 miles. So let's find the actual distance between Dallas and Houston if the distance on the map is 4.5 inches. Well, let's set up a proportion. So what do we know? Well, we know the map distance. We want to find the real distance. So on the map, 1 inch is 50 miles. And remember, when we're making our proportion, we want our inches to be in the same spot, and we want our miles to be in the same spot. So we don't know the real distance in miles, but we know, I labeled these wrong. Map, real. Okay. So we don't know the real distance in miles, but we know the map distance is 4.5 inches. So let's call this, I don't know, M for miles. And there you have it. We set up our proportion. Now to solve our proportion, we need to find the cross products. So we'll multiply 1 times M and 50 times 4.5. So we have 1 times M equals 50 times 4.5. Now this simplifies really easily. 1 times M is just M. And 50 times 4.5 is going to come out nice too. That's 225. So the distance between Houston and Dallas is 225 miles. So that's a map is like a scale drawing. What if you had a model? It's like a sculpture kind of thing. So you have the Titanic, and it was 880 feet long in real life. When a movie was made, about 80 years later, a 44-foot-long model was created for special effects shots. That's so fun. This is one of my friend's favorite movies, actually. Fun fact. So find the scale that was needed to design the other parts of the model. All right, well, let's write a proportion. Let's put the real length and the model length. So we know its real length was 880 feet long, and its model length was 44 feet long. And we want to know, okay, well, how much in real life was represented by 1 foot on the model. So let's just go full math and say x feet. So x, real feet, is how much on the model. Now that we've set up our proportion, let's solve it. So our cross products, we want to find 880 times 1 is equal to 44 times x. So that gives us 880 times 1 equals 44 times x. Well, 880 times 1 is 880. And now to solve for x, we need to divide by 44. 880 divided by 44 is an even 20. And on this other side, our 44s are going to cancel out, leaving us with just x. Awesome. So the scale of the model was 1 to 20. Isn't that great? Great. Well, remember to find the cross products as you write proportions and to keep the same things in the same spots. So put all the map lengths together, the real lengths together, or the model lengths together, the real lengths together. Notice that it doesn't matter if I have the model on top or on bottom. So here I put the map, which is the model, I put that on top, and then down here I put the model down on bottom. It doesn't really matter as long as all the models are in the same spot and all the reals are in the same spot. So that's so fun. I hope that you have a great time on your homework and that you are model students.